Here, this code explains the procedures of obtaining the root of the functions via false position method. So here we are initializing our variables. We have initial values a and b. We have p, which is what we are trying to look for, the root. We have functions of a, functions of b, functions of p. We have a1, b1, c1, d1, which are the coefficients of x. We have x. We have the number of iterations which is set into 1. We have the order of the functions as well. In here, the program will ask the users the order of the functions, which we are limiting that into 3. If the user inputs 1, then we will get this form, ax plus b, which makes the functions linear. Then afterwards, the program will ask the user to input the coefficients of x. If the user inputs 2, then that will make the functions quadratic, and we will get this form, ax squared plus bx plus c. And same goes with case 1, the program will ask the user to input the coefficients of x. And lastly, if the user inputs 3, then that will make, you will get this form, x cubed plus bx squared plus cx plus d. And same goes with case 1 and case 2, the program will ask the user to input the coefficients of x. Now, once that's done, the program will ask the user to input the initial values a and b. Now, the important thing we need to remember is that whatever the initial values of a and b, this should make the resulting values of the functions in opposite signs. One should be positive and one should be negative, so that the root of the functions will lie between line a and b. Otherwise, the root will be in somewhere else. So this is our working formula, working equations to get the functions of a, functions of b, and the root, and functions of p. In here, we are recording our data by tabulating the number of iterations and the data we gathered from the calculations. So in here, if fa times fp is less than 0, then b becomes p, fp becomes fp. So this will reflect in here. This will change the variables here. If ever the condition here is met. Else, if fp times fp is less than 0, then a becomes b, fa becomes fp. So the only thing to make this condition met is that fa is positive while fp is negative, or vice versa. And the data, we keep tabulating the data and the iterations until we get the repeating values of the root, or until we get the root. So, for example, we have like a quadratic function. So, we'll get this form, ax squared plus bx plus c. So, for example, we have x squared minus 2x minus 1. We enter the coefficients of this. So, x squared, we have 1. Bx, we have negative 2. And c, we have negative 1. Here, I will show you what will happen if we input the initial values, then that makes the functions both positive or negative. So we input a and b, 1, 1. This will surely make the functions be both positive or negative. Here, you won't get any root. So let's go back. We have quadratic functions of -1, -2, -1. Then let's say we have -1 and -1 as well. So it's the same. But if we are trying to make the functions be both positive and negative, 2, let's input again 1, -2, -1. 1, and we will have 1 and -1. So get these values, and We have 8 iterations and we get the root here because it is repeating. So that's it.